Now, starting from the very first conversion that we have already discussed is the first conversion is if you want to convert from a binary number to a denary number. This is what we have already discussed into the last class. That means that I am converting from बेस 2 to बेस 10। बाइनरी की बेस क्या है, मेरे पास 2 होती है, और मुझे जाना किस पर है, बेस 10 में जाना है। बेस 10 के अंदर मुझे जाना है। फॉर एग्जाम्पल मेरे पास कोई भी बाइनरी नंबर मौजूद है, राइट, लाइक 1 1 1 0 0 1 0 1। I want to convert this binary into base 10 binary number. So the solution is simple. As I discussed with you that I'm going to write the same series 1 2 4 8 16 32 64 128, and now what I am going to do is I'm going to copy the series exactly right here. So this is going to be like 1 1 1 0 0 1 0 1, and then I am only going to work on to the values that are provided to me, like this value, this value, this value, this one, and this one. What is the reason? Because they are settled as turned on. These are the values that are on. So these are the only one that are to be counted. So 128 plus 64 plus 32 plus 4 plus 1, and you have your final answer. So your final answer right here is 128 plus 64 plus 32 plus 4 plus 1. This is 229 in Denary. This is what we have done in the last class, and this series, ये series यहाँ पे कैसे आई? The series is basically the multiples of 2 is to power. This is 2 is to power 0, this is 2 is to power 1, this is 2 is to power 2, this is 2 is to power 3, and so on. And why I'm taking 2? Because it has only base 2. Other than that, the second conversion that we have already discussed is converting from denary to binary, and I think you are having some sort of problems into that. So this is also simple. If you want to convert a denary number into binary, you can do that easily. Like for example, if you have a number 60, this is in denary, and you want to convert this in binary. So what you have to do is that you need to again write the same series, and the same series. Why is that? Because it's we are converting it into a binary, and the same series is the one that is associated from 2 is to power. So this goes like 1 2 4 8 16 32 64 128. Now within to this series I want to make the number 60. मुझे number 60 बनाना है series के अंदर से. So am I going to take the first number which is 128? No, I'm not going to take it, because it is going to be a number that is larger than 60. I do not want any answer that is larger than 60. So this is going to be 0. Am I going to take 64? No, I'm not going to take it, because the answer is going to be larger than 60. Again, 0. Am I going to take 32? Yes, I'm going to take it, because it is less than 60. And by taking this number and adding the other values from the right hand side, I can make the exact number that is 60. So 32, I have taken it. So should I take 32 plus 16? So 32 plus 16 gives me 48, and still the number is less than 60. So I'm going to take it. So should I take 8? Yes, I will take it, because right now it is giving me a number around 56. 56, 57, 58, 59, 60. That means that I need 4 more. So I can take it from right here. So this makes it 60, and this one goes like 0 and 0. So if I add 32 plus 16 plus 8 plus 4, you are going to have your final answer as 60. And similarly, this is your final answer, which is 0 0 1 1 1100. Any confusion still here?
Also,
Now, the next conversion that we are going to discuss is that how can we convert from binary to a hexadecimal number? And for converting them, first of all, if I have a question, right, like 1 1 1 0 0 1 0 1, this is base 2, and I have to convert the answer into base 16. You can remember this base 16, right? Like for this is hexadecimal always, and how it is like some of the ways which you can remember is that, for example, if I give you an example of a hexagon, so a hexagon is always of side 6, and what is the base number of a decimal? The base number of a decimal is also 10, so that also makes it base 16. So base 16 is always has numbers that are from 0 till 9, and then 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. This is it. Now it says that I need to convert this binary number into a hexadecimal number. So for the solutions for it, the first thing that I'm going to do is that I'm going to break these eight. You need to understand that right here you have 8 bits number. This is a 8-bit number. You have 8 bits. How is this possible? This is possible, right? Like 1, 2, 3, 4, 5, 6, 7, 8. This is a 8-bit number, right? So for breaking an 8-bit number, you can break it into set of 4 into two areas, right? Like your step 1 is going to be break the number into two sets, 4 each. That means 1, 1, 1, 0 is going to be on the left hand side, and again 0, 1, 0, 1 is going to be on the right hand side. So this is it. Now what I need to do is that I need to implement the number series right here. And the number series are for converting a binary into hexadecimal is 1, 2, 4, 8. This is 1, 2, 4, 8. And why it is 1, 2, 4, 8? The reason is that if I add 1 plus 2 plus 4 plus 8, it gives me 15. And the numbers from 0 till 15 makes it base 16. And this is the reason that I am working on the hexadecimal. यहाँ मैंने 1248 क्यों लिखा है? मैंने इसलिए लिखा है क्योंकि जब मैं इन सबको ऐड कर रहा हूँ तो मेरे पास बन रहा है 15, और 0 से 15 तक नंबर्स होते हैं 16, जो इसकी बेस 16 बन रही है. अब बेटा, जस्ट आफ्टर एडिंग these numbers, now what you need to do is that you just need to add the numbers that are considered as on, that are considered as 1. So first of all, this is on, this is on, this is on, this is off. No need to consider this. No need to consider this, consider this. No need to consider this, consider this. So 8, 9, 10, 11, 12, 13, 14. The answer is 14, and 4, 5, 5. And again, 14 is A, B, C, D, A, B, C, D, E. For E, 14 is E, and 5 will still remain the same. So the final answer for this question is E5 base 16. Do you get it? Do you have any confusions?
सर वो उसमें मतलब जो आपने नंबर नहीं लिया.
Now let's check another example of the same question. Now, if I want to convert this number, which is 1, 1, 1, 1, 0, 0, 1, 1. This is again a binary number, base 2, and I want to convert this number into base 16. So for this, what I'm going to do is that again, I'm going to have the same series right here, which is 1, 1, 1, 1. And then the series on the right hand side is going to be 0, 0, 1, 1. This is it. Now I have broken it down into 4 sets of into 2 sets of 4 each. Now what I'm going to do is I'm going to implement this right here. 1, 2, 4, 8. 1, 2, 4, 8. Now you can see from right here that I will be taking all of these 8, 9, 10, 11, 12, 13, 14, 15. 15 is going to come right here, and then 2, 3. So 15 is going to be considered as F, and this is going to be 3. The final answer is F3. Any queries in this? Any questions? Hello, are you still here? Now let's discuss that how can we convert a hexadecimal number into binary. Like for example, if you have a number which has base 16 and you want to convert that number into base 2. So what you are going to do is the method is going to be same. So for example, if you have a number like C5 base 16, this is in hexadecimal, and you want to convert into base 2. So the solution is pretty simple. You are just going to break it into 2 areas. Since you have two numbers, C is going to be right here, 5 is going to be right here. And what you are going to do is that you are going to implement 1, 2, 4, 8 here. and you're going to implement 1, 2, 4, 8 here. Now you need to remember that in hexadecimal, we have 0 till 9, then 10 is associated as A, 11 is associated as B, 12 is associated as C. So that means I need to make C here. So starting from the left hand side, 8, 9, 10, 11, 12, 0, 0. This is it. For the 5, this is going to be 0. 4 is going to be turned on. This is going to be 0, and this is again going to be 1 because 4 plus 1 makes it 5. So the final answer right here is 1, 1, 0, 0, 0, 1, 0, 1. Any confusions? कोई सवाल?
नहीं सर.
Let me give you another example. For example, if I take a number which is f6, this is base 16 and I need to convert that into base 2. So what I'm going to do is that I'm going to take this number, f is going to come right here. This is going to be 6. This is again, I'm going to implement the same series of 1, 2, 4, 8, 1, 2, 4, 8. And for your F part, F is 12 is C, 13 is D, 14 is E, and 15 is F. Now, what I'm going to do is I need to make 15 here. So I'm going to set all of the values as on, and I'm going to set 0, 4, 5, 6, 0. So this is my final answer. 1, 1, 1, 1, and again 0, 1, 1, 0. This is it. And the questions that you can practice along with it, or if you can convert FA 16 into base 2, if you can convert A07 base 16 into base 2, if you can convert 7F base 16 into base 2, to be if you can convert a Denary number into hexadecimal. That means that you are converting from base 10 to base 16. So for example, if you have a question like 45 of base 10 and it says that you need to convert it into hexadecimal. So the first thing that you are going to do is first of all, you need to convert the denary number into binary. So you know it already. So for converting 45 into binary, what I'm going to do is I'm going to create the same number of series 1, 2, 4, 8, 16, 32, 64, 128, and then what I'm going to do is I'm going to place the number. So 128 is the number that is greater. I'm not going to consider it. I'm not going to consider 64. I'm going to consider 32 because it is a number that is less than 45. So if I add 32 plus 16, this makes it 48. So I'm not going to take it. I'm going to take 32 plus 8. So 32 plus 8 makes it 40 and I need 5 more. So 1, 0, 1. So the answer that I'm having right here is 0, 0, 1, 0 and 1, 1, 0, 1. Now this is your answer. Now the second step you need to do is that we have already done the conversion and we need to convert binary into hexadecimal. So there is actually another method as well in which you can directly convert that, but I feel like this is easier than that. So if you want to convert this binary into hexadecimal, you know it already. You are going to place 0010 here, and you are going to place 00101 right here. And then what you are going to do is that you are going to apply 1, 2, 4, 8, 1, 2, 4, 8 again right here. And for converting this into hexadecimal, this is 2, this is 8, 9, 10, 11, 12, this is 13. So this is 2, and in hexadecimal 13 is D. So the answer is 2D of base 16. So this is how you convert a Denary number into hexadecimal. First of all, you need to you need to take the number into binary, and then from binary you need to take it into hexadecimal. Is this clear?
Yes. Yes, sir.